Good morning, everyone. Dear students, today we are going to discuss what is a limit, basic concept of limit, limit of a function, what is the neighborhood of a point, what is left-handed limit, what is that of right-handed limit, why the limit of greatest integer function does not exist. We shall try to solve some questions also along with the basic, the conceptual knowledge of the limit section. So let us start with the very first definition, basic concept of the limit. Dear students, limit of a function. What is limit of a function? The function f of x is said to tend to the limit L as x tends to any given point A. If the given point A, if given a positive number epsilon, there exists a positive number delta such that this condition will be followed. Modulus of f of x minus L is less than epsilon. This epsilon is any positive number. This is supposed such that the difference of the given function with that of the limit, this difference is very small, very close to zero. Also, one more number delta is supposed here, and the condition for the supposition of this delta number is that x minus a, its modulus is positive but smaller than this delta. So if this condition is followed, we can write the above expression as limit x approaches to a, f of x is equal to L. That is, there is any function, and if the value of x tends to a, the answer becomes L. Dear students, let us try to understand with the picture the basic concept of limit. Suppose there is the Cartesian plane xy. This is the line y is equal to x, inclined at 45 degree to x-axis. So if there is any point p xy which is moving, if this pxy point, we draw any perpendicular on x-axis as well as on y-axis, then pn is y, this on is x. If this point p is moving towards origin, of course, of the course of movement, suppose this P point reaches here at P1. Here the coordinates becomes x1, y1. Now we see that earlier this was n point, this is n. Now the value of x is approaching towards n1. Now this has become n1. Thereafter it will again try to reach towards origin. But we are discussing about the limit of the function. This line which is inclined at 45 degree, this is the curve, and name of this curve is f of x. Now when x is changing, y is also accordingly changing, right? So the value of y, earlier this was om, now this has become om1. Earlier this was x, the distance was on, now the distance has become on1. So as x tends to origin, there is a change in y. As n moves towards origin, n approaches towards n1, x moves towards o from right side. It is moving from right side towards origin. Similarly, if we take any point here and its tendency to approach origin will be from left hand side. So tending from right side is called right hand limit. If x approaches towards origin, then this tendency from left to towards origin is called left hand limit. Dear students, in this section we shall also discuss why limit x approaches to 0 e raised to power x minus 1 upon x is equal to 1. We shall discuss why limit x approaches to 0 sin x upon x is equal to 1. Why limit x approaches to 0 a power x minus 1 upon x is equal to log a. And why limit x approaches to 0 log of 1 plus x upon x is equal to 1. What is a limit? What is left hand limit? What is right hand limit? And what is neighborhood of a point? Dear students, first of all, we know that sine of x, this is the expression of sine of x, expanded form of sine of x, x minus x raised to power 3 upon 3 factorial plus x raised to power 5 upon 5 factorial minus x raised to power 7 upon 7 factorial plus x raised to power 9 upon 9 factorial and so on. Now in the next step we are going to divide by x both sides. Now what happens? This becomes sine of x upon x, taking x common in the right hand side, in the numerator. So x in the numerator, x in the denominator, they get cancelled. So we are left with 1 minus out of x cube, this is now x square upon 3 factorial, no change. Out of x raised to power 5, this has remained x raised to power 4 upon 5 factorial, and likewise other terms also. Now in the next step, taking x approaches to 0. Wherever you find x, you put 0 in the right hand side. Limit x approaches to 0 is the operator which is assigned to the left side here and here. So now what happens? We see, except the first term, all the terms contains x in the numerator. So as soon as x approaches to 0, all these terms, no matter they are in plus or they are in minus, all these terms, they will come to be equal to 0. So we are left with only 1. So this is the famous formula, limit x approaches to 0 sin x upon x is equal to 1. Standard limit. This is the standard limit. My dear friends, once again, we know that exponential function in the expanded form is this. E raised to power x is equal to 1 plus x upon 1 factorial plus x square upon 2 factorial plus x raised to power 3 upon 3 factorial plus x raised to power 4 upon 4 factorial and so on. Now what we are going to do? We are subtracting by 1 both sides. Minus 1 in red ink in the left hand side, minus 1 in red ink in the right hand side also. So this plus 1, this minus 1 outside the bracket, they get cancelled. So we are left with x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorials. Other terms are not changed. So in the very next step, we are going to divide left hand side by x as well as right hand side by x. So in the right hand side, each and every terms contain x. So taking that x common, this x in the numerator and denominator, that will get cancelled. So we are left with 1 plus x out of x square. This is now x upon 2 factorial. This becomes x square upon 3 factorial, x cube upon 4 factorial, and so on. In the next step, insert this limit x approaches to 0 both sides. So right hand side, first term is 1, and except this first term, every term that contains x. So as soon as we put x is equal to 0, that is x approaches to 0, all the terms becomes 0. So the result is limit x approaches to 0, e power x minus 1 upon x is equal to 1. Now we have the next concept. We know that a raised to power x can be written as exponential of log a raised to power x, e log. When they are together, they will become 1. E raised to power log of a raised to power x. They are same. Here one thing is point noteworthy, a is greater than 0. Now this is a raised to power x is equal to e raised to power log m raised to power n. That means this x from the exponent will come here in the base. So x into log of a. So we have a raised to power x is equal to, now what is e raised to power x? In the previous case, here we have seen e raised to power x is equal to 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial plus x power 4 upon 4 factorial. So in the next example, in place of x, what is there? X into log a. So let us discuss that. Here in place of x we have x log a. So a raised to power x is equal to 1 plus x log a plus x log a whole square upon 2 factorial plus x log a whole power 3 upon 3 factorial, and so on up to infinity. Similarly, subtracting by 1 both sides, minus 1 in red ink. So what happens in the right hand side? This plus 1, outside the bracket this is minus 1. They will get cancelled. We are left with x into log a plus x log a whole square plus x log a whole power 3 up to infinity. Now in the next step, we are dividing both sides by x. So in the numerator, everywhere we find x is available. So we can take this x outside the bracket. So outside the bracket, this x in the numerator, in the denominator there is also one x, so they will get cancelled. So after that, every term will contain x except first term, and the first term is log of a. So the formula becomes limit x approaches to 0, a raised to power x minus 1 upon x is equal to log of a. One more formula is there to be explained. Dear friends, we know that log of 1 plus x can be written as x minus x square upon 2 plus x cube upon 3 minus x raised to power 4 upon 4. These are the basic results. These results should be on the tips of the students. So now what we are going to do, we are going to divide by x both sides. In the numerator, x will be taken out. This will get cancelled with the denominator. So after applying limit x approaches to 0, both sides, the result of log of 1 plus x upon x is equal to 1. My dear friends, now we are going to discuss about the neighborhood of a point. What is the neighborhood of a point? Let A is any point. This be a real number, and one more number delta is supposed here. Supposed this delta is a very small positive real number. Then the set of all real numbers lying between A minus delta and A plus delta. Mean to say we are moving a little bit left side of A and we are moving a little bit right side of A. Then these all the set of all the real numbers in between this and this is called the neighborhood of A. So according to this, we can discuss the existence of limit. Limit which is written as limit x approaches to a f of x. This limit is said to be exist. If this limit will exist only if left-handed limit is equal to right-handed limit. Left-handed limit is denoted as limit x approaches to a, this minus sign in the superscript form of f of x, and right-handed limit, this is written as limit x approaches to a plus sign f of x. Dear friends, now let us discuss the Perking rule to find left-hand limit and right-hand limit. First of all, to find left-hand limit, which is denoted as limit x approaches to a minus sign of f of x. Here what we do, we put x is equal to a minus h, where h is considered greater than 0 but very small number. So as x approaches to a, h becomes 0. That is h approaches to 0. So in the next step, we write limit x approaches to a minus of f of x is equal to limit h approaches to 0 f of a minus h. That is, we replace this x by a minus h. Similarly, to the right hand limit, we take limit x approaches to a f of x. Here, in place of x is equal to a minus h, we move towards right side. Here we moved towards from left side. Here we are moving from right side. So a plus h, something extra in a. This was something subtracted from a. So again h is greater than 0. Here also, as x approaches to 0, x approaches to a, h approaches to 0. So limit x approaches to a, right side limit of the function becomes limit h approaches to 0 f of a plus h. Dear friends, we shall try to understand this with one example. Examine limit x approaches to 6 of greatest integer function. This denotes greatest integer. So as we know that in the xy plane, 1, 2, 3, 4, 5, 6, 7, these are the numbers. So here x belongs to closed open bracket 6, 7. So as x belongs to this strip, then the value of y is 6, 6 to 7. This circle is dark. It means this is included, but 7 is not included. In this strip, 5 is included, but 6 is not included. So, greatest integer function definition says that if x belongs to this strip, then value of y is 6. From 0 to here, what is y? This is 6. So, a is equal to 6, h is greater than 0, x approaches to 6 from left side of a limit. We put a minus h in place of a, this is 6, 6 minus h. Mean to say, if we subtract something, a little quantity, even a little very small quantity from 6, then this strip changes. This becomes this strip now. Mean to say, x belongs to then 5 to 6, closed bracket, 5 to 6, closed open bracket. So therefore, as x approaches to 6 from left hand side, 6 minus h, the value of y is 5. Value of y is 5. But if we take limit x approaches to 6 positive side, mean to say, if we add any very small quantity in 6, then the number remains in the strip. So value of y, this height is 6, then this height is 6, value of y is 6. So in the left-handed limit, the value of the function becomes 5. In the right-handed limit, the value of the function is 6, because left-handed limit is not equal to right-handed limit. So we say that the given function does not exist. Dear students, let us try to understand the same concept with one more example. Examine the limit of the function x minus 1 upon modulus of x minus 1 at as x approaches to 1. So first of all, we discuss about left hand limit. Left hand limit, we put this superscript minus sign here. This is the given function. So when we take left-handed limit, what we put? This is x approaches to a. In place of a, this is 1. We put a minus h in place of x. A is 1. So 1 minus h. This minus 1 is already here. In the denominator also, we put x is equal to 1 minus h. So here in the numerator, 1 minus 1 cancelled, we are left with minus h, as well as in the denominator we are left with the modulus of minus h. So because h is greater than 0, this is positive, but this modulus sign makes this positive. So answer is equal to minus 1. So left-handed limit gives the limiting value equal to minus 1. Now we are going to discuss about right-hand limit. Right-hand limit mean we put a plus h in place of x. A is 1, 1 plus h. 1 plus h in the denominator also. So 1 1 cancelled, 1 1 cancelled. In the numerator, this is left h. In the denominator also, we are left with h. H cancelled, this is 1. But this one is of a positive sign. In the left-handed limit, the sign of 1 was negative. So we see here, left-handed limit is not equal to right-handed limit. It means we can say limit does not exist. Limit of the given function does not exist. That's all of the day. Thank you very much. Thank you for watching.